Okay, significant figures. So, these rules, these are very important and they need to be memorized because they will show up all throughout the semester anytime we're doing calculations, experiments, or just on worksheets, okay? So we need to practice these. Number one, all non-zero digits are significant. These are any counting numbers. 3, 5, 6, 8, 9. Anything that's counting that is non-zero, okay? Non-zero. Okay, number two, all zeros that are sandwiched are significant. 0 sandwiches. So this means that there is a number like this, and there is a 0 that is sandwiched right here. This one, this 0, is significant. We count it. We want to include it in our answer because it's sandwiched between two non-zero digits. So another example: 305,301. Okay. Well, same thing applies. We have 2 0 sandwiches now. Okay. So both of those count. Another example. Let's go into a decimal. Let's do 0.406. Okay, it's behind a decimal, but same rule applies. It's a 0 sandwich. There are 2 non-zero digits. Next rule, any leading 0 is not significant. Okay, so anytime we have 0, 0, 0, 3, 4, okay, these zeros, they're in front, not significant. Another example, let's do 0.0034. Okay, there's a decimal. It doesn't matter. These are still leading. Another example. Let's do 0.000.34. Well, there's a decimal. Doesn't matter. Leading zeros. We don't count them. Never. Okay. Rule 4. Trailing zeros are only significant when there is a decimal point. Okay, this is the one that people get tricked up on most. Right here, only significant when there is a decimal point. Okay, so let me do some examples. Trailing zeros. Let's do 37,000. Okay, well, there's no decimal point. I don't see one here. So these trailing zeros are not significant. Let's use the same number, 37,000, and let's put a decimal there. If y'all can see that. Okay, well now these are significant because there's a decimal point. Another example. Let's do 0.006820. Okay, well, what do we say about these guys up front? Well, they're leading zeros. There's a decimal, doesn't matter. These zeros don't count. That's rule number 3. How about this last one here? Well, it's a trailing 0. Is there a decimal point? Yes, there is, right here. So that last 0 is significant. Rule number 5, numbers expressed in scientific notation are always significant. Okay, so if we give a number such as 5.327 times 10 to the 5th, okay, all numbers are significant. Okay, so let's give one with some zeros. 6.02 times 10 to the 6th. Well, there's a 0 sandwich right here. These are all significant. How about one last one? 2.000 times 10 to the 10. Okay. We only look at the coefficient, which is the beginning number, and there's a decimal, and there are trailing zeros. All significant. There's 4 there. Okay, we're just going to go and plug and chug and do some examples here. First one. Okay, 28.45. Rule number 1. No zeros, they're all counting numbers, so they're all significant. There are 4 here. Okay, let's go below it with 305. Rule number 2. Any zeros that are sandwiched between numbers are significant. 1, 2, 3. There are 3 significant figures here. Okay, let's go up here. 0.000000005. Okay, all of these. Rule number 3. Leading zeros. Never significant. There is only 1 sig fig here. Okay, next, moving on. 408,109. Well, zero sandwich there, zero sandwich there. Those zeros both count. So we have 1, 2, 3, 4, 5, 6. We have 6 sig figs there. Okay. Let's go below it. 0.4567. Okay, we have a leading zero. It is not significant. Rule number 3. And then the rest are counting digits. 1, 2, 3, 4. So we have 4 sig figs here. Below that, 14.00000, a bunch of zeros. We have trailing zeros here. All trailing. They are only significant if there's a decimal place. Well, there is a decimal place right there. So they're all significant. So let's count them. We have 1, 2, 3, 4, 5, 6, 7, 8. We have 9 sig figs. Next example. Well, scientific notation. So all of them are significant. 1, 2, 3. There are 3 here. Okay, let's go to the far right. 8,760,000. Okay. I see that there are 4 trailing zeros here. Now, do I see a decimal? No, I do not. It is not there. So that means that these last zeros are not significant. So if I count up 8, 7, and 6, we have 3 sig figs in our answer. Okay, let's move down to the bottom. This is a massive example with several rules in it, so let's get to it. Okay, first off, I see leading zeros, never significant. Last off, second off, I see a 0 here, which is sandwiched between the 2 and the 5. So, that 0 is significant. Okay, lastly, I see that there are 5 trailing zeros. Is there a decimal? Yes, there is a decimal. So these trailing zeros, by rule number 4, are significant. So, let me do my counting. It's going to start at this 2, 0, 5, 6, 7, and then 1, 2, 3, 4, 5 zeros. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 10 sig figs in this number. Very large, very complicated. And we use 3 different rules. Okay, so a type of problem that we'll see is having a number and being asked to round it to a certain amount of sig figs. So let's start off on the left here with 256,782. And I'm just going to work my way down using a smaller and smaller amount of sig figs to round to so that you can see how the number changes. So the first one is rounding using 5 sig figs. So in my number there are 6 figs. 6 sig figs. So I'm going to count over 1, 2, 3, 4, and 5. And those are the 5 sig figs that I want in my final answer. So I'm going to use the next number in line, which is this 2, to round so that I can get my sig figs. So my new number is 256,000. 700 now, I'm going to use the 2 and it rounds down, so nothing changes. I'm going to have the 8 in there. Well, I can't just leave my number without a final placeholder because the integrity of the number changes. It's not the same number anymore. So I have to put a 0 there for a placeholder. So, in my final answer, there are no longer 6 significant figures, but there are 5. The 0 is not significant according to rule 4 of trailing zeros. So let's move on to the second one using 4 sig figs. Same thing, I'm going to count out 1, 2, 3, 4. Now I'm going to use the next number in line, the 8, to round. So my new number is 256,000. And the 8 rounds the 7 up because it's greater than 5. So now that 7 becomes an 8. I throw in my placeholders. And now my number is 256,800. And there are 4 sig figs in my final answer, no longer 6. Next example. Using 3 sig figs, I'm going to count 1, 2, 3. I'm going to use the next number in line to round, which is the 7. So my new number is 250, and the 7 rounds the 6 up to a 7. So 257,000. Fill in my placeholders with zeros. Next example, I'm going to count 2 sig figs over, and I'm going to use the next number in line to round up, which changes my number to 260,000. And there are 4 zeros, but there are only 2 sig figs in my answer. Last one, we're going to use 1 sig fig, and then we're going to use the next number in line to round, which is this 5, which bumps it up to a 3. So now it's 300,000. And you can see how the number of sig figs that we use to round can really change our number. So we've gone from a real specific 256,782 to 300,000. Okay, just a few more examples here. On the right, we have 0.006789, and we want to round using 2 sig figs. Well, first off, let's look at these zeros in front. Well, they're leading zeros, and so they're not significant. Okay, so we're not going to use those in our final answer. So let's look at our first few sig figs. We have the 6 and the 7, and those are the 2 that we want to round with, so we're going to use the next number in line, which is this 8, and it's going to bump that 7 up. So our new number is 0.0068, and that's it. We don't want to include any more digits, because if we include any other zeros after this, we're going to bump up the number of our sig figs. According to Rule 4, trailing zeros only count if there's a decimal. Well, there is a decimal, and so those would count. So we don't want to include these, because we only want 2 sig figs in our final answer. The zeros that I included are still leading, and they're still not significant. And so we still have 2 sig figs. Next example, we want to round using 4 sig figs. So I'm going to look, and I see a 0 sandwich right here. And on the far end, I see 2 trailing zeros, which are also significant. So in this number, all of the digits are significant. So we're going to count 4. 1, 2, 3, 4. We're going to use the next number in line, which is this 4, to round the 6. So our new number is 1.02, and the 4 doesn't round the 6 up, so it stays a 6. And again, we don't want to add any more zeros or any more digits, because then we're going to change the number of sig figs in our answer. So our final answer, 1.026, is left with 4 sig figs. Last example, we have 1 point and then a bunch of 9s, and we want to round to 2 sig figs. So they're all significant. There's no zeros in my answer. So the 1 and the first 9, those are the 2 I want, and I'm going to use the next digit, which is another 9, to round. So this 9 will bump this 9 up, which will again bump up the 1 to a 2. Okay? So if I leave this 2 by itself, well, there's only 1 sig fig. So I need to put my decimal and add a 0 to make sure that I have 2 sig figs in my final answer. So here I'm just going to work through a few scientific notation examples. Okay, so the first one, 4,400. The decimal would be to the right of this last 0. I'm going to move it over 1, 2, 3 to get to the right side of that first digit. So it's going to be 4.4. And I move the decimal 3 places over, so times 10 to the third. And because this is a large number, that exponent of the 10 is going to stay positive. 75,000. The decimal's here. I'm going to move over 1, 2, 3, 4 spots to get to the right side of the 7. So now 7.5 times 10 to the fourth. And again, it's a positive exponent because it's a big number. Okay, last one here. We have 575,004,000. So the decimal's on the far right side. We're going to move 1, 2, 3, 4, 5, 6, 7, 8 places to get to the right side of that 5. So we have 5.75. Now, I can't stop at that 5 because there's a 4 still in my answer right here. So I need to include it. So I'm going to include 0, 0, and 4. And then we move the decimal place 8 times. And it's positive because it's such a large number. And that's my final answer. Alright. To the right side here, we're going to work with some decimals. So we're going to be moving the decimal the other way. So I'm going to move the decimal 1, 2 places to get to the right side of the 8. So now our number is 8.4 times 10. Now, it's 10 to the 2, but since we moved the decimal to the right, it's going to be a negative number. Anytime that we're going from a decimal into scientific notation, our exponent's going to be negative. So let's do the next one. We're going to move our decimal 1, 2, 3, and 4 places. 4.67 times 10 to the negative 4th power. Last example. Move my decimal 1, 2, 3, 4, 5, 6, 7 places to make it 5.151 times 10 to the negative 7. So when we're moving back from scientific notation into standard notation, we're going to look at our exponents and at our power of 10 to determine which way the decimal moves. So here I have a positive 2, which means I'm going to move my decimal to the right, 1, 2, because a positive exponent means that I have a large number. So my new number after I move the decimal is 903. Next number, so I have 7.89 times 10 to the positive 3, so I'm going to move my decimal to the right, 1, 2, 3. Well, I have a spot open, so I'm going to fill it with a 0 there. So I have 7,890. Last example here on the left side, our power is positive 6, so we're going to move our decimal to the right, 1, 2, 3, 4, 5, 6. And we're going to fill in our zeros right here. So we have 3, 2, 0, 1, and then 3 zeros. So I'm going to fill in my commas. So that's my final answer. Okay, over here to the right side, we're going to look at our power, which is a negative 2, so we're going to be moving our decimal to the left 2 places. 1, 2. We're going to fill in our 0, so we have 0 point, that's where that decimal is, and there's a 0, 5, 1. Oh, excuse me. And this 0 that I added right here, that's okay because it's leading and it's not significant, so it doesn't change the integrity of my answer. Okay, next example. There's a negative 4, so we're going to move our decimal back 1, 2, 3, 4. Fill in our zeros. So on this one, I'm going to forget that first 0 I put in, but I'm going to include the ones that I wrote. 1, 0, 4. And that's my final answer. Last example, we have a negative 5. 1, 2, 3, 4, 5. Fill in my zeros. 0.000077. That is my final answer. When adding and subtracting, we need to look at the decimal places. So in the first example, 35.2 and 17.3, we're going to subtract those. Now, in the final answer, what we need is to get, well, basically we're wondering how many digits to put after the decimal place. And so with multiplying and dividing, the rule's a little different, but with adding and subtracting, we look only to the digits that are to the right of the decimal place. So in this first example, there's only 1 digit to the right there, and there are 2 digits to the right here. So when we actually subtract that out, our answer is 18.07. And we want to use in our final answer the fewest amount of digits that we used when we were subtracting. So what do I mean by that? Well, in 35 there was 1, in the 17 number there was 2, and because there was only 1 here, we're only going to use 1 digit after the decimal place in our answer, which means we're only going to use this one. But that doesn't mean we just stop there. What we need to do is use the 7 to round. So our final number is actually going to be 18.1. That is our final answer. So let's try it again. When we actually subtract all of these, our answer is 174.56. Okay, well, how many digits are we actually going to use in our final answer? Well, let's look at our numbers. So in the first one, there is only 1 digit after the decimal place. The next number there are 2, the 6, and the 4. And what about our last number? There's actually, there's nothing. We have no decimal, we have no digits afterwards. So that means in our answer, we cannot use any decimal places. So that means we're limited. So we're going to use all these. We can't use any of the decimal places, so we're actually going to use this 5 to round. And it's going to bump up our number to 175, and that is our final answer. Okay, the next one. When we do this in the calculator, our answer is 90.42. So we have 2 digits after the decimal place there and 1 here, which means in our answer we can only use 1. So we're going to use the next number in line to round. So our new final answer is 90.4. All right, last one. A lot of decimal place, or a lot of digits after the decimal place. So when we finally add it, we are getting a number 150.98489389292. So we don't want to use all of those digits. We can't use all those digits because we're limited. There are only 3 digits after the decimal place here, and here there are a whole bunch. So we're limited to 3. So we're going to count 1, 2, 3, and we're going to use this next number in line to round. So our new and final answer is going to be 150.98, and that 8 rounds that 4 up. So 985, and that is our final answer. So with multiplying and dividing, instead of looking to the right of the decimal place, we're looking at the sig figs in the whole number. Okay, so let's look at the first one. We have 1, 2, 3, 4 sig figs, and on the other number we have 3. Okay, so when we actually multiply this out, we get 421.192. Okay, so in our answer there are 6 sig figs total, but because there are only 3 in this number, we're limited to 3 sig figs. So I'm going to count 1, 2, 3, and we're going to use this next one to round. We're not going to use these. So our final answer is going to be 421. Okay, next example. When we multiply all that out, we get a number 8210.204964. Okay, well, that's a ton of digits, so we want to make sure we check. And so in this first digit, we have 1 sig fig only. There's 4 sig figs here, and here there are 1, 2, 3, 4, 5. There are 6. Okay, so we want to use the least amount of sig figs, so in this 2 there are only 1. So that means in our final answer we can only use 1 sig fig. Sounds kind of weird, but that's how it works. So we're going to use this 2 to round. So our new number is going to be 8, and we fill in our placeholders here just like that. Now, we do not want to include a 0, because if we do 8,000, if we put a point decimal and we add some zeros, well, now all these trailing zeros, because of this decimal, are all significant. So now in our final answer we would have 1, 2, 3, 4, 5, 6 sig figs when we can only report to 1. So be careful. Okay, now we're dividing, and the answer we get is, we get a repeating, so we get 8.3333, and those repeat. Okay, so in our answer we have 2 sig figs here, and we have 2 sig figs here. So that makes it nice. We can only use 2 sig figs, so I'm going to count 1, 2, and we're going to use this next number in line to round. So my final answer is 8.3. Last example, when we do that, we get 7.8 960551974012999 and a few more digits. So that's a bunch. Let's check our sig figs. So we have 1, 2, 3, and in this number we have 1, and these 2 zeros count because it's a sandwich, and a fourth one. So we can only use 3 sig figs here, so we count 1, 2, 3. We're going to use this one to round. So our new number would be 7 point. Oh, excuse me. It's going to, this 9 bumps the 8 up to a 9, so 7.90. And that's our final answer.